Okay, like I said, I wouldn't be here. Today. You should have just finished the skills check, and so we'll go through these notes pretty quickly so that you can get started on the homework. Today we're going to look at different properties of logs, just like the exponential stuff had properties, which we'll kind of go over quickly at the beginning. Your logarithmic terms will also have properties that you will need to know. Again, we talked about that right there. So you got y equals b to the power of x. Then x equals log base b of y. Those are just the inverses of each other. You can take that exponential, fish hook it to get to the log base b of y. So to just quickly refresh your exponential properties, if you're multiplying like bases, you would add your exponents. If you were dividing like bases, you would subtract your exponents. If you got a power to a power, you would multiply those. This next one is just that rational to radical. Okay, maybe not necessarily a property, but if I was to have to go from rational to radical, that's how I would do that. And then if I got anything to the power of 0, that is going to equal 1. So let's look at the actual properties that we would have with the exponential. If I've got log base b of uv, all I'm really looking at is what is going on right here. Okay, I've got two things that I'm multiplying together. I've got u and I've got v. I can expand multiplication, which is what is happening there, with addition. So if I've got two things, I've got u and I've got v, each one is going to get their own log base b. So I would have log base b of u plus log base b of v. If you have natural log, your rules are exactly the same. So your product rule, one way you can think of it is I can expand multiplication by addition. I can condense addition by multiplication. And you'll see what I mean here in a minute. Whenever we do expand, condense, you'll be given some kind of problem, and it'll either ask you to expand it or condense it. So next I've got my quotient rule. So same idea. I've got two things. I've got u and I've got v, two variables, and I'm dividing there, and I can expand division by subtraction. So earlier I was multiplying, and so I added. Here I am dividing, so I'm going to subtract. Each variable is going to get its own log base b. If it's natural log, that will not change the property. I'm just writing natural log instead of log. So you can look at this, is you can expand division by subtraction, and you can also use this property to condense subtraction by division. Alright, this last thing right here that I'm going through, last we'll have the power rule. So if you have log base b, and again I'm focusing on this part of it right here, so we've got u to the power of n, so you've kind of got an exponent in your logarithmic. Okay, what you can do with that, and this is one that it's kind of an oddball, but once you get used to moving it back and forth, it's pretty simple. I'm going to move that to the front, and I make that a coefficient. So I've got n log base b of u. Again, natural log, nothing changes. So I've got n natural log of u. So what I usually write, how I write this, the first two are kind of easy with the expand, multiplication by addition, and division by subtraction. What I will normally say to this is you can expand exponents by coefficients. You can condense coefficients by exponents. Okay, and again, on all this condense, expand stuff, you'll see what I mean here in a minute if you hadn't already looked at the bottom half of this front side of the notes. That's all we're going to do down there, is just work on this expand, condense stuff down there at the bottom. So, the first set of these is going to be expand. So on the first one I've got log. Remember, if there's no base down there, that's your common log, so it's log base 10, but you don't have to write that 10 every time. And then I've got 5 times x, so I'm multiplying 5 and x there. So if it's multiplication, I'm going to expand it by using addition. And the 5 is going to get its own log, the x is going to get its own log. So I end up with log 5 plus log x. Coming over here to number 2, I've got log base 3 of x to the 7th. So this is my power rule, the third one that we talked about. And I can expand exponents by using coefficients. So I just take that 7 and I just move it to the front. Make it a coefficient. There you go. Alright, going to 3. So a little more involved on this one. I've got natural log. Natural log does not change the properties. We're going to do the exact same thing as if it said log. I'm multiplying 3 things. 4, x squared, y cubed. I've got 3 bases there that I'm multiplying together. Each one of those is going to get its own natural log. So I've got natural log 4 plus natural log x squared plus natural log y cubed. Now that I have those expanded, 2 of those 3 have an exponent that I need to deal with. I'm going to move those to the front of the log that they're attached to. My first one is fine, natural log 4. Then I've got plus 2 times natural log x plus 3 natural log y. And that would be that one fully expanded. Alright, so now on number 4, I've got 2 parts in there. I've got the 10 and the 3, and they're being divided. So I can expand division. Sorry, let me backtrack. So the 10 and the 3, they're each going to get their own log base 4. And because I'm dividing 10 and 3, I can expand division by using subtraction. Sorry, that should be log base 4. Alright. So number 5, kind of combining a few things here, because I've got multiplication happening here, and then obviously it's a fraction, so there's some kind of division. So I'm going to have natural log. I'm going to start in the numerator. I've got natural log 6. Now because I'm multiplying 6 and x cubed, I'm going to add here. So then I've got natural log x cubed. And because I'm dividing, I'm going to subtract natural log y to the 4th. And then I'll just move those exponents to the front of the logs that they're attached to. And that would be that problem fully expanded. Going to 6. If you have a radical in there, you want to change this to rational. And we talked quite a bit about how square rooting something is the same as raising it to the power of 1/2. Okay, so now this is a little bit different than all the other exponents that we've had, because on all the other exponents, like number 5, and then even number 3, there weren't parentheses around it. So if there's parentheses, the first thing I need to do is that power property. So I'm going to take that 1/2 and I'm going to write it in front of the log. So I've got 1/2 log base 3 of 9x. And now whenever I expand that, this 1/2 has to be on both of them. So whenever I expand this, I can write it one of two ways. I can either write 1/2 and then use parentheses, log base 3 of 9 plus log base 3 of x. Or I can just write it on both logs. Okay, so that's expanding it. You're taking one term, each one of these had one term, and we expanded it, most of them, into multiple terms, okay, except for number 2. So now, whenever you're asked to condense something, you're going to be given multiple terms, and it's going to ask you to condense it down to one single term. So everything we just did now in the reverse order. So here I've got coefficients. I want to make those exponents. So I've got natural log 2 to the 6th plus natural log y to the 4th. I can condense addition by using multiplication. So I would have natural log, and I can go ahead and write 2 to the 6th, that's 64, because that's what it equals, times y to the 4th. On number 8, again I've got some coefficients, so I need to move those first. So I've got log x to the 5th minus log y to the 4th. Because I'm subtracting, I'm going to divide. So I've got log x to the 5th over y to the 4th. Going to number 9, I've got addition, so I know I'm going to condense that with multiplication. But first I have a coefficient that I need to deal with, so I'm going to have log base 5 of x to the power of 1/3. So now I can condense those. So I'm going to have log base 5 of 4, but now kind of like above we had the square root that we changed to x to the power of 1/2. Here we have x to the power of 1/3. We want to change that to the cube root. So that is going to be that one, completely condensed. Okay, we're actually going to skip number 10 so that we can move on to the back side of this. So looking at 11, 12. 11, 12 is just something. It's just something a little odd. That it's a way to practice the expand condense a little bit, and it's just kind of a two-step problem, because it will then give you a value that you would need to plug in for log base b of x, b of y, b of z, so that the answer you get is actually going to be a numerical answer. So looking at 11, I've got log base b of x times y, so that's a multiplication that I'm going to expand with addition. Log base b of x plus log base b of y, and then it's being divided by z, so because it's division, I'm going to subtract. And then you just use the key, because it says log base b of x is 4, log base b of y is 3, log base b of z is 2. So you would do 4 plus 3, which is 7, minus 2, and so you would get 5 as your answer. Going to 12, so you would have log base b of x plus log base b of z squared, but then you can move that square to the front and make it the coefficient. And so now you've got log base b of x, which it says is 4, plus 2 times log base b of z, which is 2. 4 plus 4 is going to give you 8. Okay, so what I want you to do for the rest of the period is you've got this in-class practice. Okay, you got a few more problems. I want you to work together on this. The key to this is going to be on my desk. So whenever you feel like you've got all of that, I want you to come up here. I want you to check your work, and you need to pick up a copy of the homework. Okay, so if you have any questions, I will be back on Monday, so you can come in, or no one will be here on Monday. I'll be back on Tuesday, so you can come in and you can ask me questions then. Have a good weekend.